So hopefully you had a good spring break, and this is the latest update on our website as of March 13th. So we're gradually moving in the direction of using graphical user interface. And our next project is going to be, our next challenges assignment for, is going to be complete an intro to NetBeans and GUI building tutorial, which we will do either at the end of this week or next week. For now, we still have some outstanding work to do with this, but this is generally the direction in which we're moving. This is going to be pretty much the reading chapters are chapter 15 and chapter 16, so we're clearly trying to shift our attention to graphical user interface, except that one big item still to deal with is that we have to talk about the exceptions, because what we're planning to use is the Swing package for graphical user interface gadgets, forms, windows, user controls, some utility methods that can give you support for graphical user interface programming, and the entire framework which is available from Swing library and in general Java standard support for graphical user interface is based on inheritance. So we need to understand inheritance and classes. We covered already inheritance. We also need to understand the use of interfaces, and there we're going to be seeing much more interfaces being put to real use during graphical user interface programming. And also we need to touch base on the topics related to exceptions. So I'd like to run a quick quick slide presentation on exceptions. Just talk about all the keywords that are involved, things to remember, and we're also going to run a small demo, small project which will allow us to practice with exceptions and even create our own exception class, and maybe see how we can customize those exceptions if we wanted to use our own exceptions in our project, in our own application. So that's the plan. So as soon as we're done with coverage for exceptions, we are going to shift our attention almost entirely to graphical user interface for a while. Okay, so that's the plan. So if you take a look at the course outline, the exceptions are on the list right here. We have exceptions, and so I'm just going to open the presentation. By the way, it's covered in chapter 14th of the book, but we have to grab our attention and cover it now because we're going to need exceptions during our conversation, like I said, covering GUI. So exception is, overall exceptions are essentially generalized term for errors, right? So in the design or idealistic view of software world, what happens is that you have a normal workflow, everything is going as planned, and suddenly there is a situation that has to interrupt that normal workflow and needs to be handled somehow based on some alternative decision, right? So for instance, you're trying to withdraw money from an account and there's insufficient funds. So what do? You could return back an error code, or you can generate an exception which will indicate to the system that something extraordinary just has happened, and the way to deal with such exception would be to perhaps have or at least try to find a part of the program that can handle that error and even possibly recover from that error and continue on the rest of the business that this application is trying to represent, right? So exception is a generic term for multiple types of errors that can happen. So examples here listed: division by zero, trying to open an input file that doesn't exist. By the way, just an enormous number of exceptions are associated with input-output, especially with inputting information, because this is definitely an unknown piece, so that when your program is written, it expects certain inputs and certain formats and even certain actions from your user, but there's no way to predict whether that's really going to be the case at runtime, because files can get corrupted, services become unavailable, and user, generally speaking, just doesn't follow the rules and could make all kinds of mistakes. Cat could walk on the keyboard and things like that. All right, so so essentially, that's the topic of our discussion today, and the question is, what could we do in our program to handle an exception? I think we already started this conversation before the spring break, and we kind of discussed the possibility that you could write code. And by the way, it's a kind of traditional approach in C programming, where you can say, okay, I have some computation taking place inside my method. So what I could do is just basically have every method which does something essential return the result of that operation or computation or formula or call into the database system, and indicate whether that attempt to execute that part of the program was successful. So if it was successful, everything should continue as planned. Otherwise, you can have an if, or else if, and so forth type of statements, which would analyze a specific error codes and respond accordingly to that particular error, right? So could certainly take an alternative path of execution. There are at least two well-known problems with this approach. Problem number one, it is difficult to maintain this program. Why? Because realistically, when you base your design, your coding, on the fact that majority of your methods return back an error code, you end up with methods which, like perhaps more than 70% of the code, just deals with exceptions or errors or problems, right? So essentially, the problematic part here is that your normal workflow scenario is, unavoidably is twisted and tangled with error handling code. So basically, error handling code becomes part of normal workflow. That is not desirable, right? It would be more desirable if we could have a normal workflow and the error handling workflow completely separate. So the question is, how can this be done? And the answer is going to be, of course, exceptions. But there is a second problem with this approach. The second problem with this approach, where we have methods returning error codes, is that the only chance for you to deal with error is to immediately react to that result and analyze where there was an error or there was no error, right? So you cannot neglect the error handling part, because if you neglect it, you're going to lose the keeping track of errors. You need to do this on a constant basis. However, the problem is that this current method may have not enough information to deal with errors. So of course the answer would be, okay, you can create methods or functions which could be called in case of an error to gather more information and do the right thing to handle the error. But at the same time, it would be more natural if we could just have specific areas of our program dedicated to error handling. And those areas of the program then can be, can be organized and designed in a very, very specific way, so that the rest of the application really can care less where exactly the error has occurred. Okay, so that's, once again, it can be solved with exceptions. And please, you can ask questions anytime you want. If you'd like, to participate in a discussion or have some thoughts about exceptions. So then, exception handling is, generally speaking, is an object-oriented approach to handling errors. And so this approach is this. Let me just do a very quick demonstration, maybe. So let's see. Let's just go do some very simple illustration here. So for instance, I have method, right? And this method has instructions. And so this is method A, right? So it calls into method B. And this method B has some code, and it does a lot of execution of the real code, right? And all of this, of course, has access to the data, right? So we have the data, and so this is the code, right? And this is the data that we're using, local variables, objects, and so forth. So the exception handling mechanism is based on the fact that if there is a problem detected right here in this code, what is happening here, instead of returning back an error code, which would be the traditional procedural approach to handling errors, right? So instead of this, what we do is that we create an object, right? We create an object which we call an exception object, and we say we throw it, right? We throw it. When we throw is, by the way, is a keyword. And when we throw this object, what happens is that the methods return, so method B returns back to A, and A returns back to X, whatever called it, and the code keeps searching for, or the return mechanism really in this case, keeps searching for the handler for this specific exception. Okay, so it's possibly in method A, I have a code here dedicated to error handling. So it's guaranteed that this area of code will be given a chance to examine this exception object and do the right thing with it. So alongside with this, there could be alternative scenarios, like, for instance, you can rethrow this object again and preview the error and continue error handling even at higher levels of your application, or even generate different types of exception objects depending on the situation that you have. And so this object-oriented approach to error handling provides a lot of flexibility. Of course, it would require alternative coding, but it's not really any worse than if-else or else-if series of checks for different types of exceptions. And in many ways, this is more efficient to deal with.